gaseous law, Boyer's law, relating pressure and volume. This is the for fixed P and N, PV is a constant. PV equals constants. First law relating the volume and temperature. For fixed pressure and N, volume is proportional to T. Avogadro's law relating volume and moles N. Volume is proportional to the N for fixed P and T. Hamilton's law relating pressure and temperature. For fixed volume and N, P is proportional to T. From these relations, we can get the ideal gas equation. For PV is constant for constant T and volume divided by temperature is constant for constant P and N. So PV divided by T is a constant. V divided by N is a constant. So PV divided by NT is a constant. This is the PV equals to the constant times NT. So the constant is R. And this is ideal gas law. PV equals nRT. T is temperature. In K, N is moles. Yes. P is pressure. V is volume. R is the universal gas constant. R is a universal gas constant. This ideal gas law expresses all possible relationship between four variables: pressure, volume, temperature, and the number of moles. How to decide the R is from standard temperature and pressure. Temperature is 0 degrees Celsius. This temperature, this pressure, and this volume. From here we get the R with the different number and the different units. Now we see the exercise. Oxygen generator in some airplane are based on the chemical reaction between sodium chloride and iron. Sodium chloride and iron produce the oxygen. How many grams of the sodium chloride are needed to produce 125 liters of oxygen at the 1 atom and at a temperature of 20 degrees Celsius? This is the T, this is the pressure, this is the volume. How to analyze this problem? First step to determine the moles of the oxygen. moles oxygen P oxygen, volume oxygen, constant, and temperature. Pressure is the one atom atmosphere. Volume is the 125 liters. R equals the 0.08206 atmosphere, liter atmosphere, mole. K. Temperature we can get the moles of oxygen is the 5.2 oxygen. From this equation, we can see this is one more, 1 ratio. So we can get the gram of the sodium. We need this one. We know that is the we need calculate the sodium chloride with this equation. Oxygen 1 moles sodium chloride 1 moles oxygen 1 ratio is the 100.44 gram sodium chloride. You can get this. For the kinetic molecule theory, for the ideal gas, we assume that gas molecules separate by a large distance, and the molecules move in this is the chamber. We have molecules have the large distance between molecules. Molecules move constantly and randomly collide randomly, elastically with the molecule and the walls. Average kinetic energy is proportional to the absolute temperature of gas. Kinetic energy. Gas molecules continuously collide elastically with one another with the continuous wall. One another at the continuous wall. There are no force of attraction and repulsion between molecules. This is for the ideal gas. A different kind of molecules. For the chamber of have the molecules, they have this the speed. This the fraction of the molecules. Relative number of the molecules. They have this distribution. Distributions. From this curve, we can calculate this is the most probable speed, Vm. With this speed, have the most the number of molecules. We can calculate this one. Also, the average molecules on this. This is average. Average. Another is the root mean square speed. Root mean square root. This is the equals to the square mean, square mean, and root this number. From this curve, we can calculate this is the equals to 3RT. For the average kinetic energy, this for the equals to m. This equals to the 3RT. From this equation, we can see the kinetic energy equal to the T. Equal to the T. Dalton's law of partial pressure is this is the P P T. total. Oh, fixed volume. Total. Thank you very much.